Hello and welcome to another episode of the Text Analysis with Python series. In this episode I'm going to talk about text classification with Python. So in this episode we'll build 3 text classifiers using MultinomialNB, ComplementNB and support vector classifier to classify text messages to see if they're spam messages or ham messages. And we'll use Kaggle as our coding environment, and also we'll grab a dataset which we can find here on Kaggle. Okay, but what is text classification? So it is the process of assigning a label to a piece of text based on its content or context. For example, we use text classification to detect spam emails or messages, to predict the sentiment of a text, that is to classify a text as positive, negative or neutral, to extract topics, or to categorize documents, to put them into tech categories, business categories, politics categories, and so on and so forth. So we do these using supervised learning. And supervised text classification means that we have a group of texts, so we have news articles, for example, or text messages, and we know their correct categories or labels. How do we know that? Well, a person or a group of people have assigned these labels manually. So they read the text and they decided this belongs to this category. Now, if you want the machine to learn to predict labels for future texts, then we should give it this dataset first. So we are going to provide the machine with the text and the correct labels, and the machine should figure out in this label politics all the articles, what makes them stick together or belong to this category. What do they have in common, for example, that separates them from other texts. Now this is a process. So we'll have the data set. We have a text columns and a label column. Now before getting to the classification, we need to prepare the data. Well, you could remove the stop words. For example, the doesn't contribute to classification. Doesn't add any value that we'll see, okay, because of this, for example, the probabilities of this text belonging to politics is high. No, that doesn't contribute to that. So stop words in this specific case might not contribute. Besides these actions or tasks, we need to also turn these words into numerical formats because machines know numbers. So there are several methods we can use, but we'll use TF-IDF, which stands for Term Frequency Inverse Document Frequency. And what it does, it has this formula to add a weight or importance or significance, I mean statistical significance, to a word or an expression. If something occurs in all documents, it doesn't have any significant value for this specific category, for example. So it calculates the frequency of a term in a document, and then there's a formula that it kind of tries to see, okay, what about in the whole corpus, and then it calculates and gives every word a weight. So we'll deal with only the words that matter, basically, and we'll get rid of those that do not matter. So once we have that vocabulary, it's time to train our model. So we say, okay, now let's choose a classifier, for example, naive-Bayes algorithm or support vector machine algorithm. Then the model will start training on a part of our data set, let's say 70 or 80%. So 70 or 80% of our data will be allocated only for training the model. So it will train or practice on it to learn from it. So it will learn from this data set, the 80%. And after that, we say, okay, now that you've learned, hopefully, let's test it on the rest 20% or 30%, and then we'll evaluate the performance of our model. Okay, so now let's go to Kaggle.com, and if you don't have an account, just sign up, then go to create, click on new notebook here, and then you will have this environment. The first block, you just import NumPy and pandas, so that's good. So let's just run it as soon as you see it here. On the right panel here, you have add data. So if you click on it, you will see you have access to thousands of data sets. So you can simply filter them out. So now what I want to see is a data set on text spam, something like that, text spam, and you will see a lot of them. Let's choose this one, created by Team AI. Thanks to them, you can just simply click on it to see more spam text message classification by Team AI, and you can see special thanks also to these guys as well. Okay, now just press on this add button, takes a couple of seconds, and it's been added. Here it is. Now, in order to see the file path, you can just copy it. You can see it's a CSV file. Great, so we copy the file path. Now we want to read it using pandas. So let's create another code cell here, and I'm going to create a data frame using pandas pd.read_csv method. I'm going to paste in the file path. So now I have access to this inside the data frame, and if I want to check the first 5 rows in the data frame, df.head, and you see now we have the message here, and we have the category as well. So we have message column, we have a category column. I want to check how many distinct categories we have. So I would choose to say df category. So this chooses the column, and I'm gonna perform this method on it, value counts, and it gives me this information. We have 4,825 ham messages and 747 spam messages. So this is a bit, well, more than a bit, imbalanced data. That's why it's important to check, because if you go to this page on ComplementNB base on Scikit-learn, you'll see this specific form or version of naive based classifier or algorithm is particularly suited for imbalanced data sets, and you will see that this works really well with our data set compared to multinomial, for example. Okay, so it's important to examine your data first. Alright, now that we've done that, we know what we're dealing with. I'm going to have a list of only the text messages and have a list of only the labels. You'll see why. So I'm just going to say X, uppercase X. It's just a convention to refer to the text features, basically. So X is going to be my data frame. Which column? Message. And what about Y? The labels, like lowercase y, is going to be data frame and category. And let's just also see the length of X. So, okay, now we have access to messages in this variable and labels in this one. And we have 5,572 rows, basically. Okay. So I said in the slides, now in order to do that, well, first we need to prepare the data, right? And we'll deal with it. So, but first, before getting into this part, I am going to divide my data set into 2 parts. One would be for training, so that the model will train or learn from the data, and one would be for testing the performance and the learning, basically. So this is the way you do it. You're going to say from sklearn dot model underscore, let's see if it suggests anything. Yes, selection. we are going to import train test split. So we are going to import this function from Scikit-learn to split our data into train and test. So the way it works is like this. We are going to have from our x, which is this column, we're going to have some of them as train, some of them as test. So we say x train, x test, and the same with the categories. So we'll have y underscore train, y underscore test. And where do we get these from? From deconstructing this, what we get from the function. So we are going to split the x, this x, the whole column, and y, the whole column, and we can specify the test size as well. So we can say I want only the, I don't know, 20% of the data to be the test, and 80% would be the train. You can just adjust this. Another thing that I want to also use is the random state. And random state, you can put it to whatever number. People just choose, I don't know why, 42 or 43. You can say, I don't know, 22, for example. So this randomness means that if I run this program again, it will be run on the exact same rows and columns. Otherwise, the randomness would be, for example, it might choose, I don't know, rows 5, 8, 9 this time. The next time it might choose 4, 7, 8 or something like that. So this ensures that every time the randomness is the same. Okay, now let's run this one. So now let's check the X train. Let's see how many we have here. So I'm going to copy this. So you see here we had all the number of rows in the X was 5,500. Now we have 4,400 rows. Okay, the rest is for our testing purposes. Great. Now the next step, so we have these. The next step is to make a model that trains on these, right, and learns from them. How do we do that? Well, we're going to use Scikit-learn pipeline. So we are going to create a pipeline, and what a pipeline does is it's just a sequence of steps that this program takes. So we'll create a pipeline and we say, okay, first take this step, that is turn all the textual data into numbers, grab the most important words, get rid of the stop words, for example, and then choose a classifier, multinomial naive Bayes, complement naive Bayes, LinearSVC, or whatever. So that's what we're going to do. Let's do it here. So I'm going to create a pipeline for multinomial naive Bayes first. So we start with a I need to import it first, by the way. So from sklearn.pipeline import pipeline uppercase P. Now let's just import it here, and here I'm going to create a pipeline for MNB multinomial, and that pipeline is going to be an instantiation of this class here. So inside this we're going to have a list, and in this list we're going to specify every step with a tuple. Since we're going to have two steps here, we're going to have two pairs of parentheses. The first one is going to have this name of TF-IDF, and what it is basically an TF-IDF vectorizer. So we haven't imported that, we will do it now. But so this turns our textual data into a numerical format and does all the operations that I told you about. The next one is our classifier. It's just the name of it, and it is going to be the multinomial naive Bayes classifier. Okay, we need to import these here as well. So the first one, I would say from sklearn dot feature extraction, yes, dot text import tf idf vectorizer. And another thing is to have this multinomial thing from naive base, so Scikit-learn dot naive, do we have it? Yes, here, base, import this, and another one which is called a ComplementNB naive base. The last thing is going to be from Scikit-learn dot svm support vector machine. We are going to import LinearSVC support vector classifier. These work really well with text, all of them, especially this one and this one. You'll see the performance later. So run this. Okay, now we have this. All right. So now that you've seen how it works, how it is, I'm just going to put them all in one line now, and you'll see why. So I'm going to create 2 more pipelines for the other algorithms that we have. One of them is going to be this LinearSVC, the last one. One of them is going to be this complement naive base. And let's just change the names here, like CNB for complement and SVC as well. Okay, that's it. Now let's run this. Now we have access to the pipeline. So we are going to train this pipeline or fit it on our X train. So it's going to learn from our X train and Y train, right? So it's going to learn how it should deal with these labels and texts. So right here, I'm going to say this one, pipe MNB dot fit. We use the word fit to say that, okay, this is the learning stage, now the training stage, so it learns how to deal with those. So now it's going to be fitted on the X underscore train and Y underscore train. So it's going to be fitted on the train set, the text and the labels. After it's been fitted on them, so we can use it to predict our test, this one. But we're not going to use the labels yet because we don't want to show the labels. We just want to say, okay, try it on these, predict the labels, and then we'll compare with the correct labels to see how it works. So now that we've fitted on it, I can say, let's have a prediction. So predict MNB is equal to this pipe MNB dot, we have a predict method here, and predict it on X underscore test. So it predicts it on X underscore test. All right, now let's see what this predict MNB is. So you see an array of ham, spam, ham. So these are all the texts. This is the label for all the texts inside the X test. So it predicted ham, for example, for the first one, ham for the second one, ham, spam here. But how do we know if these are the correspond with the correct ones? So we should compare, because we have access to the correct ones as well, right? So that is why we're going to use another class here. I would say we would say from Scikit-learn dot metrics. Do we have any? Yes, metrics. Import accuracy underscore score and also classification underscore report. So let's run this and we'll see. So this accuracy score is amazing. So it just gives us that comparison. So it's going to be this, and we need to have 2 variables. The first one is going to be the ground truth, or the correct labels. Our correct labels are inside this Y test, right? And then the second one is going to be the predicted labels, like these. So if I run this, you see we have 95, almost 95% accuracy it's not that bad for multinomial. So what I can do, I can just say print, let's have a f string here formatting, and MNB, and then here I'm going to pass in this one inside, inside this, and here I can just say 2f, so that we see it with only 2 decimal points. So 95% accuracy for MNB. Not bad. What about these two? This one, complement, naive Bayes, and support vector classifier. How do these do? All right, so let's just copy this, and now, for example, for CNB, let's just copy this part of CNB here, and let's just pass CNB. I'm just going to change every MNB to CNB here as well, and here. Okay, what about this one? SVC. So we are going to check it, change it to SVC, everything here, this as well, and the predicted as well. Okay. All right, now let's see. So, wow, look, multinomial naive Bayes, 95% accuracy, complement naive Bayes, 98%, and this one, support vector classifier, 99%. For a kind of a summary of an explanation of these, you can go to IBM. They have learned classification algorithms using Python. So they just have an overview of these algorithms. You can find naive Bayes, and you can find about SVM. But as I said before, you see that complement naive Bayes specifically works well with imbalanced datasets, as we have seen here. So the best is support vector classifier, and this is in my experience, because I analyze text most of the time. That's my job basically. So support vector classifier has worked best for the data that I have. So you should check and evaluate with your own data. But there's another metric that we can use to have a kind of a better view, and that it would be classification report. So I'm just going to use it on one of these, for example. So we have the classification report, and the same goes here. That is the ground truth, or the correct labels, and the predicted labels by, for example, SVC here. And if I run this, you will see that, yeah, well, let's print that. And now you can see we have precision metric, recall, F1 score, and support. So these are something that you can just check online, but for now, F1 score and accuracy is something that we are dealing with. 99%, that's amazing. You want to make sure that you know also about these, because sometimes if you have your data set is really imbalanced, like you have 99, let's say, ham messages and only 1 spam message in there, even if the precision is 100%, well, actually that's, or 99%, that's not good, right? So you should check first. You should have a good data set, and then try to also check these measures. But F1 score is basically the harmonic mean of recall and precision, and for us is 99%. That's amazing. But can we do anything to improve this number? Yes, almost. So if you go to the pipeline, to the TF-IDF vectorizer, you can add some other stuff. For example, you can add this parameter stop words, so that you get rid of the stop words like from English. And I'm going to use this all over, so that you will see it doesn't improve everything necessarily. So I'm going to just have this. Well, maybe I'm gonna let's just say I don't know. Okay, so let's have this here. So this is going to be, oops. So this is going to be our previous one, and let's see what happens to the new one now with the stop words removed. you can see, it's interesting that the multinomial has improved from 95% previously to 97%. That's amazing. But look, SVC has decreased. And if I go a bit in more detail of this, you would see that this also has decreased, this complement naive Bayes. So it's been all be good for this multinomial. So that's what I mean when I say try several metrics. Another thing that we can do is adding n-gram range. So if you add n-grams range, if you add an n-gram range of, let's say, 1 to 3, it means it will consider n-gram. It will also consider the two sequences, well, sequence of 2 words, which happen quite often, or 3 words as well, as a kind of a factor in including it in this. So it can also make a difference. Let's see if that difference is for the better or for the worse. So remember 788. Now, okay. All right, so and gram range equals, yes, I haven't added equal. Why? Yeah, okay. So now let's see what happens. 788, remember that. Now 788 became 588. So this did not add any value to our multinomial naive Bayes. So I'm going to remove this and maintain this in stop words English, and let's remove the stop words for these, and let's keep the n-grams to see how this works. So 97, 98, 99. Okay, it's just like the past, with or without n-gram range, still works fine. So now we saw how we can improve the performance and which one works the best for most cases. Now, you might ask, okay, now how can I give it a text and see if it's good or if it's spam or ham? Well, so let's say we have this message. Let's say message is equal to you have won a I don't know, $1 million, where's the dollar sign, prize, contact us for the reward. So something like that. So that is going to be the message. Now let's see if it's ham, reward, not regard, if it's ham or spam. So what we can do, the same with the predict, let's use this one, and down here. So if I run this, you will see we get into this trouble, which is a triple O blah blah. So let's just put this inside here, and you can see now we have spam. So it predicted that very well, actually. So that's basically it. I could also assign it to, I don't know, something like this, and then we print it. That would be a bit nicer. I don't know why I put it as new. Let's say, okay, CLSF, like classified. So classified, and yes, so I see spam. Okay, so it works well, and I hope you liked this video. Please let me know if you did, and if you have any questions, ask. Thank you very much for watching and listening.